first thing we are going to do today is review these histograms. Then we are going to be able to identify parts of a box plot to determine the interquartile range. That is our goal today. So, in our histogram paper, what did you come up with for the first one? How many flights were delayed? Jacob? 21 flights. So, to find the answer of 21 flights, we need to find out the frequency, the amount of time something happened for each bar graph. We have 7. We have 1, 7, 5, and 1. If we add all those up, those are the total number of flights that were delayed. Questions on that? I think we all, as I was walking around, we did a great job on that one. Then, we have, from which age group were there the most visitors? Okay, we're going to the library. What was the age range that had the most visitors? Max? 0 to 10. I would accept 0 to 10. What might be another answer that I would accept? Becca? 0 to 9 would also be good. I will accept 0 to 10 if you understand that it has to be anything less than 10. Anything leading up until 10. But when you get to 10, it becomes into the next section of 10 to 19 or 10 to 20. All right? 0 to 9 works. I think based off last night's homework, if I remember right, the answer was 0 to 10 would be in Math Excel. Okay, that's what they used. The last question, you had to create or choose the correct histogram. What are some strategies you could use to solve a problem like this? Brogan.
Well, you could already cross off 2 in this specific problem just because the number lines underneath don't go as far as, or how high as the numbers.
Perfect. Okay? This is using the process of elimination. If you are struggling with a problem, find answers that make no sense. Eliminate, give yourself a better opportunity to get the problem right. Like Brogan said, in questions B and C, it only goes up to 35. We have 37 cars. We have 36 cars. B and C cannot be a possible answer. They could also not be a possible answer because we have 0 to 5. There are no cars from 0 to 5, and in both of these, they have 2 cars. So really, be very careful on looking at what are the ranges of numbers in your horizontal number line. All right, then between A and D, now it's a 50% chance to get this problem right. What is the correct answer? Tyson? A. A is correct. Why is D incorrect? What's one reason why you can figure out D is incorrect? Patrick?
If you count on all the numbers from like 0 or from 5 to like 9, and they're like 20 to 25, and see there's only 3 there, and then you count the rest of the numbers, there's only 2 out of every other number, except for 10 with 15, which is only 1.
Okay, good. Nice job. So you found each individual one, you checked every one. I can go ahead and check this one. If I count how many cars or how many cars were each one, this is 2, that's 1, that's 3, 3, 3, 3, and 2. This right here is 12, 14, 16, 17. Do we have 17 data values? No, we only have 14. It's another way to check why D is incorrect. Tyler.
I just think about for since we started history, but so on letter A,
Yeah.
there is one of 20 to 25.
Yep.
There is an extra one, and I was thinking like you could take off the extra one and then put it with the 10 to 50, and then it would be equal. Is that like another?
What would that be called if what Ryan is saying here, this right here is extra, and we're going to take it, we're going to put it right there. What did you just create? Hudson? Not a median. The average or the mean. Okay? I'm trying to think. That doesn't work for a histogram, but when we talked about mean and average, we talked about leveling them out. It doesn't work for mean because these are ranges of numbers, not exact numbers. But yes, if you're thinking about leveling them all out, that has to do with mean and average. Okay? Any other questions? All right. Let's go ahead and look at our guided notes then. Raise your hand if you've ever heard of interquartile range before. Not many of us. Okay, a couple of us. I want you to talk with your neighbor, and I want you to decompose this interquartile range and see if you can figure out what it means. If you look on your guided notes, we are talking about or looking at box plots. So, break down interquartile range to see if you can figure out how to find interquartile range. Go. Does anyone have a guess or they think they know what interquartile range means? Jason.
I think it means so. Since it says in, I think it's in the box, and then range makes me think when we get normal range, like from minimum to maximum. So what I did was I got the first spot that started the box, found that number, and then looked at the last spot that ended the box, and then added it.
Got it. Okay. All right. And I'll tell you because it just happened to me. I can't talk to me today, and my voice will keep going out. I'm sounding like the 6th grader, right? Last class, it happened way too many times. And you are allowed to laugh at me. It's okay. So the last class was just laughing the whole time. So, for your information. Okay, but Jason was almost exactly right. When we talk about the middle, so we are talking about our box in a box plot. Quartile, this is broken up into 4 different parts. 25%, 25%, 25%, 25%. In the range. Now, Sydney, what should have Jason done instead? Good. Instead of adding the numbers, we subtract this value minus this value. Just like we were finding the range, you take the maximum minus the minimum. A range is going to give you a number using subtraction. So, I'll go ahead and point some of these points out to you so that you know them. Your first quartile is this point right here. So everyone go ahead and label that, please. It's your first quartile. This point is your third quartile. So finding the quartile range is the third quartile minus the first quartile. The interquartile range is your third quartile minus the first quartile. That gives us the range of our box. We've already found range before, right? The maximum minus the minimum. Why might we use the interquartile range instead of the range? What is the point of finding the interquartile range when we already know the range? I want you to talk through that with your neighbor. Why would we use interquartile range over range? Go. So this question is the very last question on the front page. It says, why might the interquartile range be more useful than the range in certain situations? So why might we use the interquartile range instead of the range? Maddie. Okay, you can find the range inside the box. Well, why do we need to find the range of inside the box? Josh. Figure out what 50% of the total range is. Good, I agree with both of you, but why are we going to find the 50% range of 50%? Parker. Okay. Well, to what? Is the median the range the same thing? Median is in the middle of the data set. Anyone else? Okay, nice job, Parker. That is exactly why we would find the interquartile range, is because if we have a stray data value, it is going to throw off all of our information. So we want to know the range of the majority of the people who were close to our median, but they were on both sides of it. Because if, this is the example I'm going to give you, we scored 6 points in a football game, we could consider this a stray data value. Because what if every other game we scored 19, 18, and 17? This would be a stray data value. So, do we want to represent a stray data value in a range? Maybe we do, maybe we don't. But let's say this football game, we had some kids who were sick, who didn't play. We had some kids get hurt who didn't play. Maybe we had some people who were suspended and couldn't play. Do we want to represent our team based off something that was not an accurate representation of our team? No. Okay. And that might be the same thing if you have a stray data to the far right. Maybe the team we played was just not at the same level of competition that we were in. Maybe they had a lot of people injured. So we are looking just at the middle data set. It prevents the stray data values from interfering. Okay. Questions about that? All right, I think that's all I have for that. Again, your interquartile range, your third quartile minus your first quartile. Why don't you go ahead and answer the next question in your guided notes. Does the data set have an interquartile range of 16? If the box plot does not have an interquartile range of 16, please tell me what it is. So you do need to find each one. Okay, for letter A, in that box what? Does it have a range, an interquartile range of 16? Braden? No, what is it? 13. Someone show us how we get 13. Max?
Subtract the third quartile from the first quartile and add the
Okay, so it's 55 minus 42. You don't have this written down on your paper, please do so. Quartile 3 minus quartile 1. All right, letter B. How do we find the interquartile range? Ella? 20 minus 10. Good. Here's 20, the third quartile range. Here's 10, the first quartile range. Get an answer of 10. Then C. What'd you get for C, Macy? 16. How do we get that? Minus 99. So that's how you find the interquartile range. Now, what if our interquartile range, the number, or I should say, if our number for the interquartile range increases, what is going to happen to the graph? If the interquartile range increases, what happens to your graph? Lily?
graph's going to get larger.
How is it going to get larger? Show me with your hands. Okay, you can't show me with your hands. Okay, Rylan. Our box is here at this range. If our interquartile range increases, that means our box is increasing. So the higher interquartile range that you have, how does that affect your variability? Remember, variability is how spread apart your graph is. So Brogan. Good. The longer your box, the bigger your box, the higher the variability. Nice job. We can go ahead and turn over to the back now. Here is a data set of the lifespan of some different animals. I did not know a whale could live to be 211 years old. That is insane. Wow. I thought turtles actually lived longer than 138, but... Okay, with this information, you need to be able to find the median lifespan, the first quartile, the third quartile, and the interquartile range. So at this time, go ahead and solve for that. If you want to talk with a partner that's sitting next to you, you may. So here is your middle of your data box. Right? So now we're going to use these numbers. Now cross them off the other way until you find the middle. One number at a time.